In this video, I'm going to go over how to derive the quadratic formula and where it actually comes from. So have you ever wondered why the square root has such a defined formula and where this formula ever comes from? Why is it that whenever we solve for a quadratic and the quadratic looks like this, we can immediately solve for the roots of that quadratic by using this formula here? Well, that's what we're going to do in this video. We're going to be deriving that formula. And the first thing we're going to do is I'm just going to divide all these terms by a to get a monic quadratic. So this currently is non-monic, and I'm going to attempt to make it monic by dividing by a. So then I get x squared plus b divided by ax plus c divided by a. And this right now is a monic quadratic, meaning the coefficient of the x squared is simply 1. Now that I have a monic quadratic, I can do completing the square. And for those of you that don't have that much practice in completing the square, I do have another video on my channel. Just search Sarah Explains Completing the Square and you should find that video. So if I want to do completing the square for this, I just take the coefficient of x. So I take the coefficient of x, I add it on to this equation, and then I divide it by 2. So b on a divided by 2, and b divided by a divided by 2 is simply b divided by 2a, and then I square it. So I halve the coefficient in front of the x, halve it, and then I square it. So then I'll have plus c divided by a. But I can't just randomly add this extra term into my equation, so I'm also going to minus it away. I'm going to minus away b over 2a whole squared. So now that I have this, completing the square tells me that the first three terms that I have, the first three terms here that I have, I can factorize that into a perfect square. And all I simply need to do is take this term here and this term here. So the terms under the square, and all I can do is factorize it out as x plus b over 2a whole squared. And the x came from the x up here, and the b over 2a came from the b over 2a under the square up there. And I can fill in the rest. So if I fill in the rest, it would be plus c over a minus b over 2a whole squared. And that all equals to 0. And a tip I have when doing completing the square is take all of these constants apart from the perfect square to the other side of the equation. So if I minus away c on a by both sides, I'll get minus c over a plus b over 2a whole squared. And that equals to the perfect square. Next, I can expand out the left-hand side. So if I expand the left-hand side, I'll get b squared divided by 2a whole squared minus c on a, and that equals to x plus b over 2 on a whole squared. And I can further expand 2a squared as simply 4a squared. And now I can merge the fractions on the left-hand side of the equation. So I can times the numerator and the denominator by 4a, times the top and the bottom by 4a. And if I do that, I'll have b squared on 4a squared minus 4ac over 4a squared. And we know because they have the same bases, we can merge these fractions together over just one term. And I hope you're starting to recognize that this is starting to look somewhat close to the quadratic formula. Now, if I want to get rid of the square, the opposite of squaring is square rooting. So I'm simply going to square root the left-hand side as well as the right-hand side. So on the left-hand side, I'll have b squared take 4ac all over 4a squared, and that equals to x plus b over 2a. And we must always remember that whenever we square root, we must always have plus or minus because the negative square root is also an option. Now, if I want to get rid of the plus b on 2a, I can move this to the other side by simply doing minus. So the opposite of adding is minusing. So I'll have minus b on 2a plus or minus the square root of b squared minus 4ac all over 4a squared. And whenever you're square rooting, there is a law that says if you're square rooting a on b, so if you're square rooting some term on the top over some term on the bottom, that's the same thing as the square root of a divided by the square root of b. So we can use this in this expression here. We can say that this simplifies down to minus b on 2a plus or minus the square root of b squared take 4ac divided by the square root of 4a squared. And we can also say there's another rule in the bottom that says the square root of some term times by another term is the same thing as the square roots times each other individually. So we can also use this rule over here. So if we were to square root 4a squared, that's the same thing as the square root of 4 times the square root of a squared. The square root of 4 is simply 2, and the square root of a squared is simply a. So if I were to get rid of all this, this becomes minus b over 2a plus or minus the square root of b squared take 4ac divided by 2a. And now you notice we have the same base on both of these fractions, so we can merge them into one. Minus b plus or minus the square root of 4 of b squared take 4ac divided by 2a.